Hey everybody, and welcome back to McCardle Math Academy. In this video we are going to do another example of integration by substitution, and this time we are going to look at a definite integral of e to the negative sine theta cosine theta times d theta. So a natural selection for our substitution in this case is minus sine of theta, so we're going to set our w equal to negative sine of theta. And then we're going to find the derivative of this w with respect to theta, which is negative cosine of theta. And we solve this for d theta. So you end up with negative dw divided by cosine of theta. So this is where all the work is done for our substitution. And so we can go right ahead and make our substitution for w and our substitution for d theta up in the original integral. Now, when we do this, we are working with a definite integral, but as soon as we change to w, so we have e to the w cosine theta times negative dw over cosine theta. As soon as we do this, the bounds for our definite integral are going to change. These bounds refer to bounds on theta, whereas now we change to w. So what I'm going to do in the meantime, in the interim, is put a little asterisk for these to remind myself that those bounds need to be adjusted, or else we need to go back to the variable of theta in the end. So we'll notice that the cosine thetas are going to cancel, and you're left with the integral of negative e to the w with respect to w. Again, our bounds are unknown at this point. And finally, we evaluate this integral with basic rules. So we have negative e to the w. We won't need our integration constant here because it's a definite integral. And this is going to range from our asterisk to our asterisk. All right. And finally we go back to our thetas, so we get negative e to w, which is negative sine theta. And at this point we can bring back the bounds from the original problem to finish off this definite integral. All right. So we're going to use the fundamental theorem of calculus, and so we first will evaluate negative e to the minus sine at the upper bound of pi over 2, and then we're going to subtract minus e sine of 0. All right. Now be very careful with these negative signs. You have a subtraction sign here, and then you have these negative signs, so it's very easy to lose track of these. So just be very adamant about putting in the parentheses. So finally we use our trig knowledge, and we see that this is minus e to the minus 1 minus e to the 0. And therefore this first piece is minus 1 over e. And this next piece is minus a negative 1, which gives me plus 1. And that's my final answer. Alright, I'll see you guys next time.